equation and need to determine the value of A, B and C. The matrix equation is like this. The first step is the number of two in front the matrix. We must multiply into the matrix, so you can get the 2A, 4, 6 and 14. The next step is the number of 3. We must multiply into the matrix, so we can get the 6, 12, 3B and 6. The last is 4. We must multiply the 4 into the matrix, so we can get -4, 8C, 12 and 8. Let's for first 2A minus 6 plus 4 equal to 0. Simplifies to 2A, negative 2 equal 0. Adding to both sides give to a equal 2. Dividing both sides by 2 result in a equal 1. Now let's solve for B. The equation is 6 negative 3B and negative 12 equal to 0. Simplify to negative 3B and negative 6 equal 0. Adding 6 to both sides give us negative 3B equals 6. Dividing both sides by negative 3 result in B, and we can get the B is negative 2. Finally, let's solve for C. The equation is 4 minus 12 minus 8C equal to 0. Simplifies to 8C minus 8 equal to 0. Adding 8 to both sides give us 8C. Negative 8C equal 8. Dividing both sides by negative 8, the result is C equal to negative 1. Therefore, the solution for this equation is, we can get the answer is A equal to 1, B equal to negative 2 and C equal to negative 1.
Okay, now I will explain the question that I solved for the task 2. So the task 2 question is, Mr. Azman needs to book hotel for 2 nights stay at Kuantan, Pahang. Booking website such as agoda.com suggests the following hotels: Swiss Bell Hotel Kuantan, AC Hotel Kuantan and Laman Sentosa Boutique Resident Kuantan. So when I get the question, I list down the information and make the table for this task and make it for the 5 columns. And it have a hotel name, price, tax, breakfast and add-on breakfast per day. So the question A is write the information given in metric form. So when he write in the metric form, I make a 3 times 3 matrix times 3 times 1, and the answer is 3 times 1 metric form. So in the 3 times 3 metric form, it have a price, breakfast and add-on breakfast. 551.22 is referred to the price of the Swiss Bell Hotel. 0 is referred to the breakfast, and the 17.2 is referred to the add-on per day breakfast that I have times 2, because Mr. Azman needs to stay at the hotel for 2 nights. So you have a 2 breakfast, 2 day of breakfast. And then for the question B, determine which hotel that Mr. Azman should book for his stay at Kuantan, Pahang, and give the reason. So for the question B, I list down all the hotel and the information. So in the question B, Swiss Bell Hotel Kuantan is the first hotel I list down, and it have information that the base price is 551.22 ringgit for the base price, and the breakfast cost 13.6 times 2 night is equals to 17.2 ringgit. and the total is base price plus breakfast cost and is equals to 623.22 ringgit. For the AC Hotel Kuantan, all inclusive price is 1627.92 ringgit. That means the hotel, the tax and the breakfast cost for the 2 nights is 1627.92 ringgit. For the last hotel, Laman Sentosa Boutique Resident Kuantan, the base price is 461.20 ringgit. Include for the 18% tax, 461.20 times 80 is equals to 83.02 ringgit. The breakfast cost for the 2 night is 35 times 2 is equals to 17 ringgit. And the last one, the total is base price plus the tax and plus the breakfast cost for the 2 night is equals to 614.22 ringgit. So when I calculate all the calculation in this equation for this task, I make the conclusion. The cheapest option is Laman Sentosa Boutique Resident Kuantan, that is 614.22 ringgit. However, if Mr. Azman prefer a hotel that already include tax and has no extra charge, Swiss Bell Hotel, that is 623.22 ringgit is also a reasonable choice. However, the final recommendation is Laman Sentosa Boutique Resident due to the lowest total cost, and Mr. Azman can have breakfast at the hotel for the 2 days. Thank you.
Okay, this is the question of task 3. Firstly, a bakery bakes 3 types of cakes with the monthly cost being RM7,750 for 245 cakes. The cost for baking a banana cake, a carrot cake, a chocolate cake are RM20, RM30 and RM40 respectively. The selling prices of a banana cake, a carrot cake and a chocolate cake are RM25, RM35 and RM50 ringgit respectively. If the bakery intends to make a profit of RM1725 monthly, how many cakes of each type should be baked? Alright, firstly I use inverse method, and then I make a simplify such as x plus y plus z equal to 245, 20x plus 30y plus 40z equal to 7,750, and then equation 3, 5x plus 5y plus 10z equal to 1,725. Alright, firstly determinant, we use determinant, and then after that we use minor and cofactor, adjoint, and then the last thing we use solution to get the answer. Just that from me.
So now I will explain about Cramer rule. Cramer rule is a method used to solve a system linear equation using determinants. It applies when we have the same numbers of equation as unknowns, and the determinant of the coefficient matrix is non-zero. Step 1. Define the given system of equations. We are given the following system: x plus y plus z equal to 245, 20x plus 30y plus 40z equal to 7,750, 5x plus 5y plus 10z equal to 1,725. To apply Cramer rule, we express the system in matrix form: A dot x equal to B, where A bracket 1 1 1, 20, 30, 40, 5, 5, 10. X, Y, and Z. And then B, 245, 700, 7,750, and 1,725. Step 2. Compute the determinant of matrix A. The determinant is calculated as determinant equal to bracket 1, 1, 1, 20, 30, 40, 5, 5, 10. Expanding along the first row equal to 1 bracket 30, 40, 5 tenths minus 1 bracket 20, 40, 5 tenths plus 1 bracket 20, 30, 5, 5. Now we calculating the 2 times 2 determinants. Bracket 30, 40, 5 tenths equal to 30 times 10 minus 40 times 5 equal to 100. Bracket 20, 40, 5 tenths equal to 20 plus 10 minus 40 plus 5 equal to 0. Bracket 20, 30, 5, 5 equal to 20 plus 5 minus 30 plus 5 equal to negative 50. Thus, determinant equal to 1 bracket 100 minus 1 bracket 0 plus 1 bracket negative 50. Since determinant not equal to 0, we can proceed with Cramer rule. Step 3, we will compute determinant 1. To find determinant 1, we replace the first column of matrix A with matrix B. Determinant 1 equal to bracket 245, 1, 1, 7,750, 30, 40. 1,725, 5 tenths. Now we will expanding along the first row. We expand the determinant using cofactor expansions along the first row. Determinant 1 equal to 245 bracket 30, 40, 5 tenths minus 1 bracket 7,750, 40, 1,725 tenths plus 1 bracket 7,750, 30, 1,725 and 5. Now we calculating 2 times 2 determinants. We calculate each of the 2 times 2 determinants separately. First determinant bracket 30, 40, 5 tenths equal to 30 times 10 minus 40 times 5 equal to 100. Second determinant bracket 7,750, 40, 1,725 tenths equal to 7,750 times 10 minus 40 times 1,725 equal to 8,500. Third determinant bracket 7,750, 30, 1,725 and 5 equal to 7,750 times 5 minus 30 times 1,725 equal to negative 13,000. Substituting the value determinant 1 equal to 245 bracket 100 minus 1 bracket 8,500 plus 1 bracket minus 13,000 equal to 24,500 minus 8,500 minus 13,000 equal to 3,000. Thus, the value of determinant 1 is 3,000. Step 4. Compute determinant 2. To compute determinant 2, we replace the second column of matrix A with matrix B. Determinant 2 equal to bracket 1 245 1 20 7,750 40 5 1,725 tens. Expanding along the first row, we expand the determinant using cofactor expansion along the first row. Determinant 2 equal to 1 times bracket 7,750 40 1,725 tens minus 240 minus 5 times bracket 20 40 5 tens plus 1 minus bracket 20 7,750 5 1,725. Calculating the 2 by 2 determinants. First determinants brackets 7,750 40 1,725 tens. Multiply 7,750 by tens. Then subtract the product of 40 and 1,725. Bracket 7,750 multiplied by tens minus bracket 40 multiplied by 1,720 minus 5 equal to 70 minus 7,500 minus 60 minus 9,000 equal to 8,500. Second determinants bracket 20 40 5 tens. Multiply 20 by 10. Then subtract the product of 40 and 5. Bracket 20 multiplied by tens minus bracket 40 multiplied by 5 equal to 200 minus 200 equal to 0. Third determinants 20 7,750 5 1,725. Multiply 20 by 1,725. Then subtract the product of 7,750 by 5. Bracket 20 multiplied by 1,720 minus 5 minus bracket 7,750 multiplied by 5 equal to 30 minus 4,500 minus 30 minus 8,750 equal to negative 4,250. Substituting the value determinant 2 equal to bracket 1 multiplied by 8500 minus bracket 240 minus 5 multiplied by 0 plus bracket 1 multiplied by negative 4250 equal to 8500 minus 0 minus 4250 equal to 4250. Thus, the value of determinant 2 is 4250. In step 5, we compute determinant 3. To compute determinant 3, we replace the third column of matrix A with matrix B. Determinant 3 equal to bracket 1, 1, 245, 20, 30, 7750, 5, 5, 1725. Expanding along the first row, we expand the determinant using cofactor expansion along the first row. Determinant 3 equal to 1 minus bracket 30, 7750, 5, 1725 minus 1 times bracket 20, 7750, 5, 1725 plus 240 minus 5 plus times bracket 20, 30, 5, 5. Calculating the 2 by 2 determinants. First determinants, brackets 30, 7750, 5, 1725. Multiply 30 by 1725, then subtract the product of 7750 by 5. Bracket 30 multiplied by 1720 minus 5 minus bracket 7750 multiplied by 5 equal to 50 minus 1750 minus 30 minus 8750 equal to 13,000. Second determinants, bracket 20, 30, 5, 5 multiply 20 by 5, then subtract the product of 30 by 5. Bracket 20 multiplied by 5 minus 30 multiplied by 5 equal to 100 minus 150 equal to negative 50. Substituting the value, determinant 3 equal bracket 1 multiplied by 30,000 minus 1 multiplied by negative 4,250 plus bracket 240 minus 5 multiplied by negative 50 equal to 13,000 plus 4,250 minus 12,250 equal to 5,000. Thus, the value of determinant 3 is 5,000. Now, the last step, we compute x, y, and z using Cramer rules. Now, we will compute the value of x, y, and z using Cramer rules. The formula for each variable is given by x equal to determinant 1 over determinants, y equal to determinant 2 over determinants, z equal to determinant 3 over determinants. Calculating x equal to determinant 1 over determinants equal to 3000 over 50. Thus, x equal to 60. Calculating y determinant 2 over determinants equal 4250 over 50. Then y equal to 85. Calculating z equal to determinant 3 over determinants equal to 5000 over 50. Then z is equal to 100. Final solutions. Thus the solution to the system of equation is x equal to 60, y equal to 85 and z equal to 100. Thank you.